series RLC circuit, for series RLC circuit, we know omega naught is under root LC and Q factor is nothing but omega naught L by R. So from if we substitute here, that is 1 by R under root L by C is the Q factor. So 1 by 10 under root L is 0.1, C is 50 into 10 power minus 6. So if we solve this one, we will get it as 4.47. Hence option B is correct.
Fy by Fx, the frequency of vertical plates to frequency of horizontal plates ratio. Okay, now what is this ratio here? We have 1, 2, 3, 4, 5, 6, 7 horizontal peaks. Okay, so 7 is to, how many we have? Half plus 1 plus 1. So this is 2. Answer is 7 is to 2. So option B is the correct answer. This is Fy by Fx, the frequency of vertical to horizontal. So we have to calculate the ratio of tangents of horizontal to vertical. Okay, horizontal tangents is 7, vertical tangents is 2. 7 is to 2. Option B is the right answer.
Voltage will be of the form. Here, if the Vi is positive half cycle, then the suppose Vi is greater than 0. And what happens? NPN transistor is in on situation, whereas PNP is off. So the current is going to flow in this direction. Means this is positive and this is negative. Means output is going to be positive half, no problem. This distortion is mainly because of the cut-in voltage of the diodes, because the input diode of the transistor is not going to conduct until input voltage reaches 0.7 volts. Means till 0.7 volts the output is going to be 0. That is what appearing here. If Vi is less than 0, NPN is off, whereas PNP is on. So if that is the situation, the output will be in this form. So the current is going to flow in this direction. So this is the polarity whenever the PNP transistor is in on situation. So this is the output. So hence option D is correct.
Equation for inhomogeneous medium is, okay, Poisson's equation is del square V is equal to minus epsilon rho by epsilon. Okay, this is the Poisson's equation. Okay, option A is satisfying this relation. So answer is A. It's a continuous time system. It described in state variable form. Okay, he has given a matrix A is equal to 3 rows by 3 columns. Okay. Now, this system is stable for all values of x and y is. Okay, we have to find the satisfying values of x and y from this matrix. Okay, now what is Si minus A? Si minus A determinant should be equal to 0. So, I can write this one as S minus x into S minus y into S plus 2 plus 1 is equal to 0. Okay, substitute here Si minus A means, okay, I can write this one as S minus x 0 0 0 S minus y minus 1 0 1 S plus 2. Okay, now find this determinant equated to 0, you will get this one. Okay, now from this roots are, okay, S is equal to x and I can write this one root 1. What about S2 and S3? S2 and S3 is equal to, you all know that minus b plus or minus square root of b square minus 4ac by 2a. So this is minus 2 times of 2 minus y plus or minus square root of 2 minus y whole square minus 4 times of 1 minus 2y divided by 2. Okay, for stability point of view, this x value always should be less than 0. Okay, and 2 minus y is greater than that of 2 minus y whole square minus 4 into 1 minus 2y. Or I can write this one as y should be less than 1 by 2. It should not be equal to 0. Okay, so option D is the correct answer.
Or such that the PNP is in saturation. Okay, for PNP transistor, VB saturation value is minus 0.8. So if we apply the KVL in this loop, that is 0 minus VEB sat minus IBR plus 5 equals to 0. So R is nothing but 5 minus 0.8 divided by IB, which is 4.2 divided by IB. Here IC is given as 10 2 amps, beta is given as 10. We know in saturation IC is nothing but a beta IB, so IB is nothing but 0.2 amps. So if we substitute 4.2 divided by 0.2, which is nothing but 21 ohms, hence option A is correct.
Current of a DC chopper feeding a pure resistive load is I amperes. Okay, if a variable inductance connected in the load circuit. Okay, this is variable inductance connected in the load circuit. Now, what happens to the average load current we have to find? Okay, now let us take, this is a chopper. Okay, it might be step up or step down. Okay, let us take step up chopper. Here we have a switch, diode, okay, load R. When you have this type of choppers, okay, we have load current constant. This is I0. Okay, if there is any inductance in the circuit, what happens if you change the inductance value? Okay, charging and discharging will be there in the output current, because now the load type is RL. Here only R. Okay, this is the RL type load. Now it starts from a value to the highest peak and then reduces to the again average load current of, let us take it as I minimum. Okay, so option D is the right answer. Function of a pulse transformer in a triggering circuit is. Now what is pulse transformer? Pulse transformer is a 1:1 transformer. Okay, here the primary winding is, let us take, you have N turns, let us take it as 1. The secondary windings, tertiary windings, and let the windings be of N in the secondary side. Okay, this windings is also is equal to 1. Okay, that means what does it mean? That transformation ratio K is equal to 1. Since N1 is placed on the primary side, same N1 number of times is placed in each secondary winding. Okay, so transformation ratio K is equal to 1. That means it is called as isolation transformer, because isolating from primary to secondary. If you see option A, he has given step up the voltage of the pulse. Okay, this is wrong. Okay, if you see in secondary side here, each secondary side is connected to a thyristor anode. Okay, like this it will be there. Now, option A is wrong answer. To isolate the gate circuit and anode circuit, so the B is absolutely right. So answer is option B.